Well, hello guys. In today's video we're going to discuss about process. So in today's video we're going to introduce the notion of a process which form the basis of all computation. We're also going to discuss about the various features of processes and operation on the processes. The third one is we're going to discuss the inter-process communication. So a process is the unit of work in a modern time-shared system. The more complex the operating system, the more it is expected to be reliable to its users. So various activities happens in the CPU. So what do we call all of these activities? Given many respects, all of these activities are similar, so we call all of them processes. A batch system executes jobs, whereas a time-shared system has user programs and tasks. Even on a single user system, a user may be able to run multiple programs at a time using a Microsoft Word, using the web browser, and so on. Informally, a process is a program in execution. It contains the program code, which sometimes called the text section. The current activities are represented in the program counter and the contents of processes register. Generally, a process includes the process stack, which contain temporary data such as parameters, return addresses, and also include the data section, which contain the global variables. A process may also include the heap section, which is a dynamically allocated memory during runtime. We can say that a program is a passive entity and a process is an active entity. Loading executable files can be done by double-clicking an icon of the executable files or entering its name in the command line. As process executes, it may change its state. The first state is the new state where the process is being created. The second state is the ready state where a process is waiting to be assigned into a processor. The third state is the running state where a process instructions are being executed. The waiting state is the fourth state where a process may wait for an event to occur, for example, an input-output event or a reception of signal. The last state is the terminated, where the process has finished execution. All of the processes in the operating system is represented in the PCB, which is the process control block, or we can call it task control block. In PCB, it contains the process state, the program counter, the CPU registers, CPU scheduling information, memory management information, accounting information, and also input-output information. A PCB is used when the CPU done the context switch. A context switch is where the CPU changes processes, switches between processes. So it have to save the state of the old processes, then load in the state of the new processes, and the context of these processes are kept in the PCB as we discussed earlier. In the system existed a scheduler. The scheduler helps to determine which processes can be executed next. Scheduler helps to maintain the queues. The first queues that I can share with you is the job queue. The job queue contains a set of processes resides in the system. The second queue is the ready queue, where a set of processes is waiting to be executed. The third queue is the device queue, where a set of processes is waiting for devices. So there are few types of scheduler in the computer. The first one is the short-term scheduler, or we can call it a CPU scheduler. It is invoked frequently and the processes executes in milliseconds. These CPU schedulers or short-term schedulers determines which processes can be executed next. The second one is the long-term scheduler. This scheduler is invoked infrequently. The process may execute in seconds or up to minutes. Long-term scheduler can help to increase the degree of multi-programming. And the third one is the medium-term scheduler. It helps to decrease the degree of multi-programming.
Hello guys, my name is Wan Arya Najmi. Okay, today I would like to talk about operation on process. There are two subtopics in operation of process. First, process creation, and second, process termination. Okay, let's talk about process creation. Let's start with process creation. Process creation is when process parent create process children, which in turn create other processes and forming a tree of processes. In general, processes are managed via process identifier, which is known as PID for short. Next, when parent process create children process, the children process may need certain resources to accomplish its task. There are three possibilities existed. First, child and parent share all resources. Second, child and parent share no resources. And third, if the parent terminated and some of the operating system will not allow the child to continue if the parent is terminated. Next, when new process created, there are two possibilities of execution existed. First, parent and child executed concurrently. Second, parent waits until children terminated. Next, there are two possibilities address space existed. First, child duplicate of parent. It means the child process has all the program and data of its parents. Second, a new program has been loaded into the child process. Now guys, let's talk about process termination. Process termination is the process that executes its last statement and then asks the operating system to delete it using exit system call. Process return status from child to parent using wait system call. All process resources are deallocated by operating system when it is terminated. Next, process may terminate its child process using abort system call when there are three types of possibilities existed. Firstly, the child has completed its processes or it is no longer required. Secondly, the child has exceeded its allocated resources. Thirdly, if parent is terminated and some of the operating system did not allow the child to exist if the parent is terminated. Okay, next, cascading termination. What is cascading termination? Cascading termination is when all grandparent, parent, grandchildren, and children is terminated all at once. Next, parent may wait for the child process to terminate by using wait system call. The call will return status data information and PID for the terminated process. If no parent is waiting and did not invoke system call, the process is called zombie. If the parent is terminated without invoking system call, the process is called orphan. Okay, that's all from me guys. See you next time. Bye.
Okay, now we're gonna talk about inter-process communication. So let's get it in. A process within a system may be independent or cooperating. Cooperating process can affect or be affected by other processes, including sharing data. There are several reasons for cooperating the process. This includes information sharing, computation speedup, modularity, and convenience. Cooperating process needs inter-process communication, or IPC. There are two models of IPC, which is shared memory and message passing. Okay. To illustrate the concept of cooperating process, let's consider the producer and consumer problem, which is a common paradigm for cooperating process. A producer process produces information that is consumed by a consumer process. For example, a compiler may produce assembly code that is consumed by an assembler. The assembler, in turn, may produce object modules that are consumed by the loader. A producer-consumer problem also provides a useful metaphor for the client-server paradigm. One solution to the producer-consumer problem uses shared memory. To allow producer and consumer process to run concurrently, we must have available buffer of items that can be filled by the producer and emptied by the consumer. There are two types of buffers can be used. The unbounded buffer, which is place no practical limit on the size of the buffer. The consumer may have to wait for new items, but the producer can always produce new items. Bounded buffer assumes a fixed buffer size. In this case, the consumer must wait if the buffer is empty, and the producer must wait if the buffer is full. Okay, we've talked about inter-process communication, but how these processes are communicating? This process uses message passing, which is a mechanism for processes to communicate and to synchronize their actions. Message system process communicate with each other without resorting to shared variables. IPC facility provides two operations, which is send and receive message. The message size is either fixed or variable. If process P and Q wishes to communicate with each other, they need to establish a communication link between them, and they exchange messages via send and receive. Message passing are implemented in the physical. They are implemented in shared memory, hardware bus, and network. In logical memory, they are implemented in direct or indirect, synchronous or asynchronous, and automatic or explicit buffering. For direct communication, processes must name each other explicitly. The properties of communication link are the links are established automatically. A link is associated with exactly one pair of communicating processes. Between each pair, there exists exactly one link. The link may be unidirectional, but it is usually bidirectional. For indirect communication, messages are directed and received from mailbox, also referred to as ports. Each mailbox has a unique ID. Processes can communicate only if they share a mailbox. The properties of communication link is the link are established only if processes share a common mailbox. A link may be associated with many processes. Each pair of processes may share several communication links. Link may be unidirectional or bidirectional. Message passing may either be blocking or non-blocking. Blocking is considered synchronous. Blocking send, the sender is blocked until the message is received. Blocking receive, the receiver is blocked until a message is available. Non-blocking is considered asynchronous. Non-blocking send, the sender sends the message and continue. Non-blocking receive, the receiver receives a valid message or null message. Different combinations possible. If both send and receive are blocking, we have a rendezvous. And then buffering. What is buffering? Buffering is a queue of messages that is attached to the link. It is implemented in one of three ways. First, zero capacity, which is no messages are queued on a link. Sender must wait for receiver, that is rendezvous, as I said earlier. And then the bounded capacity, a finite length of n messages. Sender must wait if link is full. And last one, the third one, unbounded capacity, infinite length where the sender never.
So guys, let's talk a bit about issues on operating system. Have you heard about the blue screen of death? Yes, it happens in Windows computers. The screen suddenly goes blue. If you are working on something, you can no longer proceed with the job. So it mainly related to the error in the code. So another one is the slow processing. I mean, the application is becoming slowly because of mainly the random access memory. The system had not enough RAM to run the process. So many processes running concurrently will make the system slower. So what you can do is go to the shop and upgrade your laptops by increasing your size of RAM. Well, that's all for today's video. I hope you enjoy it and see you again next time.